So let us solve another problem based on EMF equation. So the question is here, calculate the value of induced EMF of 10 pole 3 phase 50 hertz star connected alternator having 60 slots and 4 conductor per each slot. So those who didn't watch the previous video and listen this watch this video so that you can understand clear information. And coil span is sorry coil span of 150 degrees, and flux per pole is 0.12 hours, and it is sinusoidally distributed. So that let us write the data clearly. See that first one is number of poles is equal to 10, phases is equal to 3, and frequency is equal to f is equal to 50. He gave 50 hertz, and 60 slots. Actually, this is for example stator, like that. These are the armature slots, and we need to place the winding here. Between the slots, we need to place the winding here. These slots are 60 available, and here conductors are available here. These conductors 4. I think, but for one slot 4, for 60 slots, total conductors that is equal to 60 into 4. Nothing but 60 slots are there. For one slot, 4 conductors are available, he gave in the question. And coil span is equal to 150 degrees. So simply you can understand coil span is 120, which means, so this is for example full pitch winding. This is the north, and this is the south. This is full pitch winding, and this is short pitch winding. Short pitch winding. For full pitch winding, this is 180 degrees. But he gave coil span as 150 degrees, means this is definitely short pitch winding, because this is less than 180 degrees. Less than 180 degrees. That's why this span is 150 degrees, which is definitely less than 180 degrees. So what is the short pitch angle? This is the angle here. This is the alpha. This is total is 180. This gap is 150. So that this span this small gap is alpha. Alpha is equal to definitely 180 minus 150, which is equal to 30 degrees. So directly he won't give short pitch angle alpha, which is equal to 30, 20, like that. So if you give that directly, no problem, you can substitute directly. But instead of giving directly, you will give indirectly to find the coil span. So that alpha is equal to 30 degrees. So I'm erasing this one. But if you want to, if you want this data, you can pause the video and you can copy. And he gave the reason. And flux per pole is how much? Flux per pole is he gave as 0.12 Webers. Sorry. And sinusoidally distributed. Okay, this is the given data. By using this one, we need to find the line induced EMF, and we need to find the line induced EMF is equal to enter. How much? Which is equal to EL is equal to root 3 times of phase induced EMF. Phase induced EMF nothing but this is the formula 4.44 pi flux for 4 transfer for frequency Kp into Kd until unless you mention in the question Kp Kd values are so and so are full pitched winding. So if you give in the question as it is full pitched winding, that's why in such cases you need to take Kp is equal to 1. For example, in the question the winding is concentrated winding, then you can take Kd is equal to 1. If you give full feature winding, then we need to take Kp is equal to 1. Until unless you want to mention about the Kp and the Kd values, you need to solve that values. So solution will be this is a flux he gave directly. How much? 0.12 that is available here. Transfer phase. That's what we need to find. Total number of conductors Z. From this Z per phase is equal to for this is for three phase. This is for three phase. For single phase 60 into 4 by 3. 3 ones are 3 twos are. So 24 is 80 conductors. So turns per phase is equal to Z by 2. I think but 80 by 2, which is equal to 40. So that we found transfer phase also. Frequency gave directly, which is 50 hertz. He gave directly. So for all problems, he will give flux directly. So we already solved a few problems. In that all problems, flux is giving directly because there is no relationship. Frequency is also is giving, but another way of giving the frequency is frequency f is equal to Pn by 120. So in this way also he is giving a number of speed instead of direct frequency, and poles also is giving, so that you can find frequency by using Pn by 120 formula. And finally, we nothing but without KPKD, it's easy to find the induced EMF. So flux transfer phase, and also he gave in the previous problem. So he gave all the conductors, nothing but total number of slots and slots per conductors he is giving, and we need to find total number of conductors, and then we need to find the total number of conductors per phase, and then we need to find number of turns per phase. So turn for phase is equal to Z by 2. Nothing but if you find the number of conductors per phase, you can find the transfer phase easily by dividing with 2. So nothing but I'm explaining the probability of asking the problem. These are the various models so he's asking, and we know flux, transfer phase, frequency, and finally we need to find Kp and Kd. So that I'm erasing this one. So for a clear, visible clearance, and I'm erasing. So we need to find Kp and Kd. Kp is equal to cos alpha by 2, which is equal to cos alpha is equal to how much? 30 degrees. So 30 by 2, which is equal to cos 15 degrees. Now 15 degrees approximately 0.96 more than 96 like this. And Kd is equal to sin m beta by 2 over m sin beta by 2. So m is equal to number of slots. Number of slots are 60. In the question also you get 60 slots, and each conductor having a 4 each slots having 4 conductors. So number of slots are 60. 60 slots per poles are 10. Number of slots per pole for phase is 3. So that is 60 by 10 into 3, 30. Then what m is 2, beta is equal to uh, number of slots per pole for phase. So slots are 60, slots per pole, poles are 10. Sorry, this is wrong. Due to the oversight, I did any mistakes. Beta is equal to 180 by slots per pole. Beta is equal to, so sin m beta by 2 by m sin beta by 2. This is, and beta is equal to 180 by slots per pole. Slots are 60, poles are 10. 60 by 10. 0, 0 cancel, 6 ones are 6 3. Nothing but beta is 30 degrees. So by using m here and by using beta, you can find kd also. So we got all the values. Just substitute these values in this equation, and you can find this. You can find EMF equation, that is phase in terms of phase value. And if you divide it with this value after calculating this, then we will get to some value, and we need to multiply root 3 and the answer. We will get a line for phase which is equal to 1722 volts. Definitely we will get. So this is all problems which I discussed based on KP and KD, based on KP and KD. And there is a problem KP and KD, and the equation is EMF equation is 4.445 m turns per phase. This is flux per phase, and F Kp into Kd. So the possibility of office, this is a flux. Flux they will give directly, but the turns are giving indirectly in the way of total number of slots is giving, and the slots per conductors are giving, and you will multiply both, so that you will get a total conductors Z. And if you divide with 3, you will get a turns per phase, conductor for phase, because here turns per phase we need to find for phase. That's why total 3 phases, so that Z by 3, nothing but you will get single phase conductors. And then turns per phase we need to find, that is equal to the relationship between turns and conductors is equal to, that is Z is equal to 2t, and turns is equal to Z by 2. Turns per phase is equal to Z phase by 2. So in this way we can find uh, this is a turns, and frequency also he will give directly 50 Hz or 60 Hz, but otherwise he will give, instead of frequency we will give speed. N is equal to such a speed, so that you can find F is equal to P N by 120. This is a relationship. So in this way we can find frequency. So there is only two possibilities. There is only two possibility to ask for the frequency, a direct frequency, and they may give a speed instead of frequency. And for Kp is equal to as alpha by 2. So there are various ways is asking, and one way is, and coil span of 5 by 6th, 5 by 6th of full pitch, like the TV is giving. And the second case is 9 slots are there, 9 slots are available, but short pitched by 1 slot, like that is giving. And another one is they will give uh, slots, 10 slots or 40 slots, and the number of poles are 3. For example, 10 poles are available, like that they will give. but and short pitched by one slot, like that they will be. So here 5 by 6 of full pitch is nothing but sixth is nothing but full, fifth is nothing but 6 slots are available. So which means 5 by 6 mean 6 slots are available, but coil is distributed in 5 slots. Nothing but otherwise the coil fully spaced with the 6 part parts. For full pitch winding, 6 parts are there. For short pitch winding, nothing but for short pitch winding, coil span are 5 parts. Nothing but one part kept empty. Nothing but short pitched. One part is short pitched. Nothing but for full pitched, how much angle? 180 degrees. For 6 parts angle, for 6 parts 180 degrees. For one part is 180 by 6. That is 30 degrees. For one part 30 degrees. So you can see here 5 by 6, nothing but a fifth part, fifth for 5 parts, 5 into 30, which is equal to 150 degrees. Nothing but this is a coil span. So short pitched by nothing but 180 minus 150, otherwise 180 minus 150 to 130 degrees, 30 degrees, otherwise for one part 30 degrees. But coil is short pitched by, look at this one, 6 over 5. Nothing but 6 minus 5 is 1. Nothing but one part is short pitch. Like that, you need to find that Kp. And here simply, in the second case, 9 slots and 1 slots are nothing but this is north pole and this is south pole. Between this one, 9 slots are available. But the winding is short pitched by 8 slots only. 8 slots only. Short pitched by 1 slot. So coil span is 8 slots. So for 9 slots, angle is 180 degrees. For one slot, 180 by 9, which is equal to 20 degrees. But short pitched by one slot. So that for one slot, 20 degrees. Number of short pitch angle is equal to number of slots short pitched into angle for one slot. So short pitched by one slot, nothing but 1 into 20. But instead of he will give 2 slots, the short pitch angle will be 2 into 20. If you give instead of 2, 3, short pitch angle is equal to 3 into 20. Like that you need to find. And the third case is, so just I'm erasing all these things so that you can understand it clearly. So nothing but why I'm explaining this one is nothing but this concept is because if we give in any model, if you give in any manner, you can solve all the problems if you understand these concepts. Nothing but how many varieties are there to solve the problems. So this is useful for your higher education also, competitive exams, higher educations for government jobs, all those things. So here 40 slots are available, 10 poles are available. So you need to find the slots per pole. For one pole, how many slots are there? Slots are 40, 40, no, 80, I'm taking 80. Pole is 10. Nothing but 8 slots. 8 slots. It's better to take 90 so that for according to my convenient I'm taking, because you cannot understand with random answers. 90 by 10, which is equal to 9 slots. But the short pitched by 1 slot he gave. Nothing but for 9 slots, slot per pole is 9 slots. Nothing but for 180 degrees, 9 slots. Nothing but 20 degrees. But short pitched by 1 slot, this is for one slot 20 degrees. Short pitched by 1 slot, so that the short pitch angle alpha is equal to 1 into 20 degrees. For example, instead of 1, if you give 2, 2 into 20 is equal to 5. Like that, we need to find but in case of KD, sine sin m beta by 2 by m sin beta by 2. But in your diploma level, m we give directly number of slots, we give slots and number of poles, number of phases. This they will give 3 directly. Number of poles you will give directly, number of slots after you will give directly. These two directly, this is also three phase directly. Beta is equal to 180 by number of slots per pole. Slots per pole is nothing but this part, this part. So if you find the m value directly, beta also can be found by using m value and only, because 180 by number of slots per pole. Here slots per pole is available here in m. While finding m, slot per pole is available here. So that KD you can find directly. So for all problems, KD also can be found directly because they will give the direct to data. Only problem is alpha, finding alpha. There are many varieties while finding alpha. This is all about the KP and KD and EMF equation based on the uh, alternator or synchronous generator. Now let us discuss a few concepts. So derivation of frequency and then synchronous speed and frequency relationships I'm deriving. Generally, in DC machines, the concept is this is north and this is south pole. There are two poles are available. This is single loop generator or conductor is available here, which is connected to the split rings like this, and this is connected to the battery like this. So, as we know all that single loop generator, for one complete revolution, the induced EMF will be for complete revolution. So nothing but this is for frequency, one complete revolution. Nothing but this is A, this is B. To change A to B, this becomes so reverses. A becomes here and B becomes here after 180 degrees. Again after 180 degrees, again if you rotate with 180 degrees, that becomes A to B like that. So this is 1 up to 180 degrees. Again 180 degrees. Total 360 degrees, it will remain same position. Nothing but for positive half cycle and negative half cycle. So this is uh, A to B and this is B to A. So uh, for one cycle, for half cycle, 180 degrees revolution. For another cycle, 180 degrees revolution. Total is 180. Total is 360 degrees. Nothing but one rotation. So for one rotation, one revolution, sorry, one revolution. How many poles are there? Two poles are there. Two poles, one revolution. For example, I'm taking four poles. One, two, three, four. North, south, and north and south. So, for example, this is a conductor. I'm taking, and this is a circular conductor. I'm taking. This is so to change from north to south, 180 degrees. Again, south to north, 180 degrees. North to south, again 180 degrees electrical. Again, this is 180 degrees electrical. So that this is two times of 360 degrees. Nothing but two revolutions per four poles. If two poles are there, one revolution for two poles. One revolution for two poles. Two revolution for four poles. Nothing but the relationship is revolution. One revolution is equal to this is one revolution is equal to number of poles by 2. For example, here one revolution is equal to number of poles are 2 are available. 2 by 2 is equal to 1. So 1. Here number of poles are 4. Here number of poles are 4 are available. If we divide with 2, that is equal to 2 revolutions. You can see here 2 revolutions. So the relationship is for uh, one revolution is equal to poles by 2 revolution per second revolution per second I am taking. So revolution. So one cycle for revolution. So one cycle for revolution is equal to number of poles by 2. So cycles per revolution. How many cycles per one revolution is equal to number of poles by 2. For example, for 2 poles, one cycle for one revolution. One revolution. For 4 poles, 2 cycles per revolution. 6 poles, 3 cycles per one revolution only. For one revolution, I am calculating. So that revolutions, sorry, cycles per revolution. Cycles per revolution is equal to P by 2. So, number of cycles per second is equal to frequency. Number of cycles per second is equal to frequency. And the speed, RPM, rotation per minute, number of cycles per. So RPM is nothing but speed, rotation per minute. So rotation per time taken for one revolution or revolution per second. Rotation per minute is RPM, but here frequency in terms of second. That's why speed also in terms of RPS, which is nothing but rotation, nothing but cycles per second. Cycles per, sorry. So RPM, revolution per. Wait a minute. Cycles per revolution is equal to P by 2. Frequency is equal to cycles per seconds is equal to frequency. And speed, nothing but N by 60, which is equal to um, revolution per cycles per revolution. Cycles per revolution is equal to N by 60 cycles per second. Sorry, cycles per second is equal to this is. So revolution per second is equal to RPS. RPS is equal to revolution per second. RPM is nothing but N. RPM is nothing but N. Speed RPM N. This is per minute per second by 60 minute divided. So now frequency is equal to cycles per second. So if you multiply, look at this one. This is cycles per revolution. P by 2 into revolution per second. N by 60. Look at this one. Cycles per revolution into. So I'm erasing this one. Wait. So this is has gone. It has gone. Wait a minute. So again I will write again. So cycles per revolution is equal to P by 2, and induced EMF frequency is nothing but cycles per second. So rotation per minute speed RPS, and or revolution per second is equal to n by 60, n by 60. So if you multiply p by 2 and n by 60, which is equal to p by 2 is nothing but cycles per revolution, and n by 60 is nothing but revolution per second. So revolution will be cancelled. We will get cycles per second. So that Pn by 6 to the 120, Pn by 120 is equal to Pn by 120 nothing but cycles per second. Cycles per second is the unit of the frequency. So frequency F is equal to Pn by 120. F is equal to Pn by 120. This is the relationship between frequency, number of poles, and number of turns. Sorry, number of speed. This is the n is the speed. So from this one, n is equal to 120 f by p. So this speed is nothing also called a synchronous speed. For a particular frequency and a particular poles, the speed is called synchronous speed. So this is the most important one, synchronous speed. The synchronous machines work rotate at a synchronous speed ns. That's why these machines are called synchronous machines. This synchronous speed is nothing but the speed of alternator at a particular frequency, and constant poles. So if the alternator rotating at constant frequency, constant poles, and that at a particular frequency and particular poles, the speed is called synchronous speed. This is all about a synchronous generator, frequency, poles, and the speed relationship.